Principal Sir, Mr. Bijbhushan Singh, who is also present in this meeting, my colleague, Amit Kumar Bajpayee Sir, Govind Lakatia Sir, and Nani Gopal Mondal. So this is possible only because Dr. Verma Sir has given his consent that he will join our workshop, and we are working for a very long term with the Nani team. So I just give a brief introduction of Nani. So please be with us.
National Anveshika Network of India, Nani, was conceived and created by Dr. H. C. Verma in 2011 as a new unit of Indian Association of Physics Teachers, IAPT. The main aim of Nani and its coordinator Dr. H. C. Verma is to guide and coordinate the activities of all the 26 Anveshikas which are spread all over the country. All these activities are centered on improving the quality of physics education through experiments, innovations, and discussions. Some of the activities undertaken by Anveshikas and Nani are cited below. The development of small and doable experiments based on various concepts of physics. The materials used are low cost, and the experiments are of short duration of less than 5 minutes, which can be incorporated in the classroom teaching. Student workshops, which are organized by all the Anveshikas, demonstrate these experiments and explain the concepts. The Anveshikas report these activities to Nani biannually teacher workshops organized by Anveshikas to emphasize the use of experiments in explaining the concepts of physics. These are also reported to Nani biannually. An annual competition, National Anveshika Experimental Skill Test, which tests the experimental skills and concepts of students in physics. This competition is held at the local Anveshika levels and then at the national level. Last year, around 45,000 students from school and college participated in this competition, which was held on a virtual platform due to the COVID pandemic. This unparalleled competition has captured the attention of the entire physics community of India. Currently, all the Anveshikas and Nani are celebrating the centenary year of Einstein winning the Nobel Prize on photoelectric effect in 1921. They are holding webinars on the historical facts, which led to his Nobel Prize, demonstration on photoelectric effect, quizzes, etc. IIT Kanpur, in collaboration with Nani, is also going to float an online course on the story of photoelectric effect by Dr. H. C. Verma on its web portal of bsc.hackverma.in from 15th July 2021. Moreover, a residential science lab has been designed in Sopan Ashram, Kanpur by Dr. H. C. Verma, where all kinds of experiments of physics are designed. Student and teachers' workshops are held regularly over there where they get a hands-on experience of doing and understanding these experiments. A map of Nani Network of India, with its 26 Anveshikas, is given below.
So thank you everyone. So we are starting our session without any further delay. Today I, Debmalya, teacher of the BGA school, Kolkata, my friend Shri Nani Gopal Mondal, teacher of Balurghat LMAU Vidyalaya, will demonstrate, and also Dr. H C Verma will have a session with you. So let me start my session. When this workshop was designed, I was thinking what to show. So it come in my mind, I'll demonstrate about light. But the main problem is, we say that we are able to see because of light, but we can't see the light. So I have thought, so the method I do where we can visualize light. So I just concentrate on the scattering of light, which make the things possible. I have just make, just please switch off the light. You can see I have made arrangement where I have put 4 color of bulbs which is almost equal of intensities. And now I am trying to introduce the scattering of light. I'm just pinning my video because otherwise I'm not able to see. So when I put some scattering surface on the blue light, we can see the light is traveling a certain distance. When I put it on the green, we are seeing that it is traveling further longer distance. So if we put that light on red, what will we expecting? It will travel more or less. So participant can raise hand for interaction, or from chat box someone please read out so I can find. So we are placing to the red. So we are finding it is traveling further more distance. So this we always tell the students that the blue scatter, blue light travel the less distance, green light travel the further more distance, and red the longest. But my question, if I put this on the white light, what will happen? It will travel further distance or less distance? It will travel more than red, less than blue, or in between red and blue.
Yeah, few participants are saying that it will travel more distance.
It will travel more distance, more than red.
Yeah.
So let's see when we put the white, what happens. So it is absolutely different thing is happening. You can find that now the colors get separated. Here we are finding there is a blue tinge. Is it visible clearly?
Yes, sir.
And end is reddish. That I can see on the camera. But if you look very closely, you can find the blue is here. So the blue light is scattering the most, and red is traveling the farthest distance as it scattered the least. And we know that the scattering is depending on the inversely proportional to the 1 by 4th power of the wavelength. So since the red is having the less wavelength, so it is traveling most, that is scattering least. And where we are finding the blue is traveling least and scattering most. I just switch on the light, top one. So this is the scattering, and I hope the scattering is can be demonstrated in this way, where we can show that how the different color of light is traveling, also what happens the when white light scatter. And this also include that why the sun appears red at the dawn and the dusk. So you can see when we look from the other end, it is just giving up orangish color. That is the color of the sun at the dawn and the dusk, because it is coming from the horizon, traveling a very long distances. So this was one of my scattering experiment. Now I have tried a further one. If anyone have any question, please you can ask me.
So there is one question. Sir, what have you used as the scattering medium? Which pipe is used here?
Sir, your voice I can't hear properly.
Yeah. What have you used as a scattering medium?
Here I have used a glue stick.
Glue stick.
Yes, the sticks available with the glue gun. I use that glue stick only. So this is, I am showing the scattering the liquid medium. I have taken a torch, and you can find the focus beam inside the water. I think everyone can see that. So now I am going to use one of the, just switch on the top light. I am using one of the polarizer. So when I'm using the polarizer, you can find with certain angle, the light is not visible. Let me remove some of the. Is it visible?
Yes.
So when I am using a polarizer, you can see that, okay, it is reflecting my camera light only. So the light is just disappear. So why this is happening? When I rotate it, it disappear. Again rotating another angle, it is reappear. Sir, I want little interaction from the participants.
Yes, participants, you can raise hands and we'll unmute you. Yeah, there is one hand I can see. Yes, you can unmute yourself and you can speak. Yes, please see on the screen and unmute yourself. Nehal Chaudhary, yes.
Sir, both have same refractive index, that's why.
Debmalya sir,
Yes, sir.
yeah.
Both have same refractive index.
Uh, Sir, refractive index will be, if the same, then from one rotation it is visible and other direction it is not. So I am not changing the refractive index of this film. So how it make difference,
Okay.
sir? I'm just rotating. I'm not. This is a polarizer plate I am using. This is a polarizer film. So I'm
There
just
are many
rotating.
hands. Debmalya sir, there are many hands. Let's move to Snehal Chaudhary, madam. Yes, madam.
Yes, sir. I was going to talk about the same, that the plate which you are using, that must be the polarizer. And when the planes are matched, we can see the light which is coming out. And when it is rotated to 90 degree, we can say that the light which is coming out through that bottle is not passing through the polarizer. So that is the reason why it is not visible.
Okay, ma'am. Thank you. Anyone else want to say anything?
Yeah, there are many hands. So Hassan sir, yes, you can unmute yourself and you can say.
Sir, I think the light is unpolarized. That is why when we rotate the polarizer, when it comes to 90 degree, it shows nothing, no light. I think light is unpolarized light.
Sir, if it is unpolarized, then from is the polarizer will make any difference on it?
Sir, due to scattering, does the light get polarized? Does it become plane polarized so that after it is unable to pass through the polarizer in one particular direction?
Ma'am, you
Is
are
it-
asking or answering?
Sir, I'm doing both.
Okay.
Unpolarized. Sorry, maybe.
Yes,
Okay.
Fatima madam. You can.
Sir, I would like to add that the component of light which is parallel to the axis of the polarizer, that is being allowed to pass through it. And when the axis of the polarizer is making an angle of 90 degree with the component of light, mainly the electric field one, then the light is not passing through the polarizer.
Okay, so we are mostly concluding that the light is polarized.
Yes, yes, sir. Light is polarized.
Debmalya sir, you are muted.
So we are thinking the light is polarized. So from here we can view the light, and from here we cannot see the light. But my question is, if I bring another polarizer between them, is there will be any change? I am having another polarizer. If I place between the light and my first polarizer, now it is, you cannot see the light. So it is now not passing through this polarizer. So it is just perpendicular plane, correct? Now if I introduce the second polarizer in between these two, so what we can expect? We can see the light or not?
Yes, Saurabh sir, you can say.
I have just blocked the light.
Sir, good afternoon. So when the plane polarized surface is again placed parallel to it, then the light will be seen. If it is placed perpendicular, then no light would be seen.
But sir, I have already blocked all the light.
In this case, no light would be visible.
Okay, sir. Anybody want to say anything?
Yes, Anuradha, madam, you can.
Yes, sir. No light will be visible when you rotate the second polarizer.
Okay, ma'am, just have a look. You can see the light. Now vanish. You can see the light vanish.
Oh.
Now, sir, ma'am, how it possible? So when I was doing this, I found that so when it blocked with the one polarizer and we introduce another polarizer in between, we can see the light. You can see. And when it is removed, light is not there.
Yes, Suman Tiwari, madam, wants to say something. Yes, you can unmute, madam.
Yeah, good evening, everyone. So actually what is happening is that the light in the light which is coming from the bulb, when you are rotating the polarizer, we see that at one instant of time it is completely bright and then it becomes dark. It means itself, it suggests that the light which is in the bulb is already polarized.
Ma'am, bulb is not polarized. If you can
Light,
see, you can see
the
I can
light,
rotate,
now
rotate
this
the
is unpolarized.
polarizer beam with the light. So bulb is not polarized, ma'am.
The light, no, sir, what I'm saying, see, now the one which you have shown, the torch light which you have shown me, it is unpolarized, of course. But if you see, you are putting the beam parallel to this, like this, and the polarizer which you are putting it is like this, means perpendicular to the propagation of the light wave.
Yes, ma'am.
So what is happening is that we know that the electric vector, it is perpendicular, and which actually contributes to the intensity of light. It is perpendicular to the propagation of the wave. So if the light is going like this, it means we can say that the light is moving in this direction. So the electric vector, if we are taking it like this, or in this plane, so what is happening is that if the path axis of this polarizer is either this way or this way, then in one case only it is allowing the light to pass, and that's what we are able to see.
Yes, ma'am, that's fine. But when I'm putting the second one, you can again see the light.
So that will happen that if the path axis of these two, both the polarizers, if when they are parallel to each other, then we will be able to see the light from this side. Otherwise, if they are perpendicular, then no light will pass.
But ma'am, when the fast polarizer is not allowing, then how when they will be parallel, they will allow?
So you may you please
See, I can show if I put in the front, it will not work. You can see that when I'm putting in the front, you cannot see the light. So when this is parallel, you cannot see the light. And I'm rotating, you can find everything is blocked. That means it is perpendicular. So you cannot see anything. But my problem is when I'm inserting in between, then you can see the light. When I'm inserting front, you cannot see. Check. But when I'm inserting back, then you can only see.
Okay. So this is a question which we need to ponder upon. That when it is put in front, because otherwise it is behaving as a polarizer and an analyzer. So you are saying that. But sir, like when you are putting
If
this, I can
somebody else, sir, you can give somebody else.
Shamanand Tiwari, sir, you can.
see some light coming.
Those who want to answer, they can raise their hands.
Yes, sir. Yes, sir. What is happening here? We need to apply the Malus law. I equals to I0 cos square theta. Theta is the angle between the axis of the polarizer and analyzer. Okay. So when you are getting more light, it means what? The angle between polarizer, axis of polarizer and analyzer is something, okay, where cos theta is not 0. That's why it is happening. angle between polarizer and analyzer. This is what happening over here.
Okay, sir. This experiment setup you can do very easily. I have used 2 polarizer and 1 torch. So I am not answering it. Hope everyone will search. And if possible, we can discuss afterwards. I am just want to show one more thing. So this time I'll try to show with the I got some. So we have seen that when the light is passing through the solution is in liquid medium and we have some scattering particles, we can visualize the light. Now I am trying to show you what happens in air. Is the smoke is visible?
Yes, sir.
Please switch off this
Can
light.
you?
So you can see, okay, I have to adjust the angle. What is happening? I have to move. Okay. Can you see the changing of the smoke? I'm again rotating the polarizer. There is no polarizer now. Now I'm inserting the polarizer and I'm rotating it. Now it's absolutely nil. You can see still the smoke is there. And you can see also the color of the smoke, the light scattering from the smoke is blue. So that can be demonstrated why the student asks us that why the sky is blue. So this can be give them an idea that when the smoke is coming and light is scattering white light, it gives you a blue tinge. And when I'm using the polarizer, I introduce a polarizer, you can find that at certain point, it is just disappeared. So this same thing can be applicable in the dust molecules present in the air. So that's all, sir, from my side.
Yes, very good discussion and very nice experiment, sir.
Thank you. And I am handing over this to Mr. Nani Gopal Mondal. He will continue.
Okay, good evening, all of you. Just I am going to share my few knowledge or few experience with you. Okay, just I am going to show which are we are reading in book or which we are teaching in our class, lower class only. That is only I am going to show you, and from there we can explore something. Okay, then I have a like this glass tumbler. We know the atmosphere is applying pressure in upward direction, all direction. Then for the upward pressure, we are using this type of experiment in our class book is given. We just will take full glass of water and I'll put like this type of one cardboard type things, and which will I'll put on this glass, and just I have inverted it, then it will not fall. That is we know this experiment. Okay, then I'm pouring some water on this glass. Now it is full. Now, what will happen? Okay, just 1 minute. Okay, then just I am putting this postcard. It is not a postcard. Okay, we can say postcard like things only. It is look like postcard. Just I am inverting it. See, it is not falling. That means we can say the atmosphere is giving upward pressure, and that upward pressure is producing upthrust, and that due to that upthrust, that liquid column is holding. But in the book, it is written we have to take full glass of water, but we can explore from there. So we can give chance to the students. They can explore like this way. If I take half glass of water like this, suppose I took now, it is visible, I think. It is half glass of water, like half glass. Then if I now do this same experiment again, it will able to hold the postcard or not? Anyone can answer also. If I take half glass of water, it will hold or not? Okay. Yes, sir.
There is one hand, and India ji, please unmute yourself.
Sir.
Yes, the board will be hold it.
Yes.
It will not fall.
Yes. Okay, I am showing. Yes, it is holding. But one problem is there. Then we can ask to the student. Then we can see here is a liquid inside the glass. There is a air, and if I just put it, then inside pressure of the atmospheric pressure or inside pressure of this gas and outside pressure is same. Just if I invert it, now also we can say the inner pressure of the gas is and outer pressure, outside pressure of the air is same. Now, when I am just releasing it, then more pressure will be there. More pressure will be there due to this liquid form. Then downward pressure should more. And upward pressure should little less. Then why it is balancing? How is it? Is it possible to balance? Okay, so many hands is rising. One can give answer, sir.
Yeah, Anupama ji, you can come up now.
When you are good evening, sir. When you are inverting, the pressure difference takes place. When you are inverting the glass, that time some pressure decreases inside the glass. That's why cardboard is not falling.
How that pressure is decreasing?
Because when the water comes down near to the rim, there will be a slight change in the pressure, I think.
Yes, ma'am. Then from there only we can give the idea about the Boyle's law also. So many things we can.
Yes, sir. Because volume increases, pressure decreases. Correct.
Simple experiment. From simple experiment, we can discuss so many things. That is, I want to share with you. Okay. And one more things also we can try here. Suppose I am not taking. See, there is no water only. Then also, if I put it, then also it will go. From there also, we can explain something. Adhesive force between the water and glass, water and this board, like that things. Like this type of experiment we can show in class in 1-2 minutes only, and we can explore so many things, and we can ask so many questions, and we can produce curiosity in the child mind also. Okay, this is one type of experiment, and next experiment I am showing to you, that is from friction. I have a match box. See, I have a this match box. If I want to say this match box stay here, it will stay here. Just if I come down, it will come down. Yes, slowly it is coming down. If I stay here, if I say stay here, it will stay here. Simply we can say like this, and we can explain the friction. With that friction only, we can do it. Okay, just this type of experiment is nothing to measure, but we can produce curiosity in the child mind. Why it is happening, how it is happening, and how is friction is changing. That things we can give the child mind. Then I can show you how this friction is changing. So suppose when tension is increasing, then friction is increased. When it is staying in rest, then tension in the state I just increased. But when tension is decreased, Then what is happening? It is coming down. Then how the tension is producing, increasing the friction between the mass box and the thread. Here is a thread. You can see, you can able to see, here is a thread, thin thread is there, and there is a hole between two end of the this mass box, and through this mass box there is a thread is going this side or that side also, both side, left side, right side, it can move. But one thing I produce inside, make inside, just thread is not straight inside the mass box. I make it little bend. That means when I'm increasing tension, I'm increasing the force on this paper or board. Then there is producing, if I apply more force on this board, then reaction force also will be more. And for that reason, friction also will produce more. By this way, we can teach to the student, or we can produce curiosity to the student how the friction is depend upon reaction force, like that things, and we can produce like this magic things also, and like this we can produce like funny things also, and student will get interest, and I'll think student will try to read and see, or try to listen your words, whatever you are delivering in your class. They will get it more interest to listen your word from your delivery. Okay, this is now another experiment which we are using in class and we are reading in book. For that purpose, just I'm changing my device little bit. Okay. See, one experiment we know. Card point experiment. For Newton's first law of motion, we are using card point experiment that to explain the inertia of rest. We are using like this type of card point experiment. I have a card and I have some coin also. I'm using one coin, like this coin is there. And what we are doing, we are putting card and coin here. Just if I apply a jerk on this card, the coin will come inside. Just not come. Again, I'm just, it's deflected. Sorry. It's becomes sticky. Okay, new this one. It is going outside. Why it is going outside? Book is written, it will fall in the glass, but it is going outside. If I hit slowly, see, if I am hitting slowly, then also it is falling outside. But if I apply more jerk, and which is parallel to the, just exactly parallel to the horizontal line, like that, now it is inside. In book, it is not written you have to apply parallel force, or you have to apply a jerk. If I apply less force, then why it is not falling inside the glass? When we are applying, I am applying less force, means force value of force is less. Then it is moving with the card only. It is falling. But if you see clearly, or then you can see this coin is hitting this on this wall, front side wall, not back side wall, or not in middle. It is hitting on the front side wall. See, it is just going with the card. That means that things also we can explain in front of the student also. Then student are doing like this. Okay, yes, experiment is given in book. we have to do it. We are doing like, sorry, I'm very sorry. Doing yes, okay, it is inertia of rest. But student can explode themselves by using less force, by using tilting means not parallel to a parallel force. So many things they can do, and they can understand about the force, and they can understand about the other things also. When I am using that is force is magnitude of force is less, it is not falling or it is hitting on the wall, front side wall. Why it is happening? Just see, just I am applying small force. Yes, it is going with the moving with the cardboard only. Okay, that things also we can ask, we can share with you, and some teacher also can give their opinion why the coin is moving with the cardboard when we are applying less force, and when we are applying jerk, then it is just falling inside the glass only.
Yeah, please raise your hand.
Yes, one is raised. Hand is raised.
Shelja ji, yes, please come.
Yes, still.
You can unmute and
Speaking, sir. Sir, the coin is moving along with the cardboard when we are applying a slow force, so that the coin is gaining the momentum of the cardboard. The time is more and it is gaining the momentum. It is moving along with the cardboard. And when we apply a very small, very high amount of force for a very small time, the time is less for the coin to gain the momentum with the cardboard, which we have just given by applying the force on the cardboard.
Yes, yes. That means we can say, yes, it is a example. We can get the idea of inertia of rest, but it is not a example exact, not a exact example of inertia. I can think we can explain things, and we can explain one more things also. Some frictional force is applying between the cardboard and the coin also. Then that force is fixed, but when we are applying less force, then it will taking more time to travel from middle to center to the end, and that means then more time is getting applying the frictional force on this coin, and if time is more, then it will its change in momentum, force is same, change in momentum is more, so it is moving forward direction, it is moving, and like that things. That things we can explain with the students, or and students can enjoy these things, and from inertia only we can explore more things also. Okay, another experiment also we are showing, same purpose only I am showing to you. That is coin and paper, which we are using like these things. This is explained very nicely. See, inertia of rest, for inertia of rest, what we are doing? Like this coin and paper we are putting like this way, and if we apply jerk on here, see, it will remain there only. But if we apply less means very low amount of force, then it will move with the paper only. Same things. But in the inertia, when we are teaching inertia, we are not telling that yes, you have to apply more force, why you have to apply more force. We are not telling about that. Jerk you have to apply. We are not telling about that, because when we are teaching inertia, inertia means if we apply force on this object, then only that force should apply on this object, but no force should apply on the coin. But here what is happening? I am applying force on the coin, but some part of the force also applying on this coin also. I am applying force on the paper, but some force of this force, some part of this force is applying on the coin also through the friction, due to the friction. That means there is a friction. That means we can't say no force is applied on the coin. Like that things we can show the students. And next experiment is very interesting. I can just wait Just I change my device. Newton's third law of motion, we can visualize to the students very nicely. See, this is two straw. 90 angle bend. I just bend two straw at angle 90 degree. I just am inserting one.
Nice, sir.
Okay, just see this one. And what is happening? Just I'm giving, I'm blowing some air through this pipe. What is happening? See. Just it is, I'm just, when I'm blowing it, the air inside through this pipe, it is just rotating. I think everyone able to see this rotation. And from here we can explain the action, reaction, like that things. Action and reaction cannot produce a balance like that. So many things we can explain from there. Okay. I'm not going to explain in this experiment. Okay. Or now we are having a experiment, very famous experiment, that is called Cartesian driver. Just I am showing to you Cartesian driver experiment. We know everyone, I think maximum teacher and student know it. I took a bottle, there is a water inside the bottle, and see one colorful things you can able to see, blue color things is there. That is a homeopathic bottle, just partially filled. But if I use only homeopathic bottle, then you can't see through this means camera or like that way, like this way. So to visualize these things, I put some paper inside the bottle, that homeopathic bottle, blue color paper. So it is looking blue. Then what is happening? Just I'm not joking with you. So just if I apply some pressure on the wall of the bottle, then what will happen? The inner bottle will come down. See, inner bottle is going downward direction. Just if I release it, it is moving upward direction. Okay, upward direction. And again you can see, if I able to adjust the force, we can keep it in middle. Yes, now it is in middle also. From here we can explain the Pascal's law, and I think here from here we can explain the Boyle's law also. I'm not going to explaining because time is not too much in our hand. Time is going over. Okay, then okay, like this. I'm just pressing and it is moving downward, and just releasing, moving upward, like this. This is called Cartesian driver. Okay, this type, that means we are going like this. Sir, Debmalya sir, you are having anything? All time, I and Debmalya sir.
Sir, I have also made one Cartesian driver. I want to show. Govinda sir, if you focus on me. Okay, so I have also a Cartesian driver. So we are working together, and the same thing is happening with me. But can anyone explain why this is happening? Please, participant. See, it can go down when I'm pressing, and when I'm releasing, it is going up.
Same thing is happening. Whatever you see in my experiment.
What might be the reason? Actually, we have taken a bottle, and inside it is water, and we put a glass bottle which is partially filled with water and partially filled with air.
Yeah, there are common hands, Debmalya sir. Could I ask them?
So
Yes.
Yeah, Sandeep Roy, sir, you can unmute yourself and reply. Yes, Sandeep, sir. See on the screen, you can unmute yourself. Yes.
Sir, actually, when you pressing it, the air pressure will be decreases. That's why this one is being moving in upward direction. Hello?
Yes, sir.
yes, sir.
Once again, sir.
Hello? I think that is
Yeah, your voice is not clear, sir. Please use the mic.
Fast actually it is floating, but when we are pressing, it is
That means the,
submerging.
hello? When
Yes.
it is I think that the inside pressure is decreases. That's why it is decreases. That's why it can move upward.
Sir, if inside, sir, we are pressing the bottle, so how the pressure can decrease? We are applying pressure from outside, sir.
Sir, I think that at the top of the bottom, top of the lid, have there some hole is there or not?
No, it's absolutely airtight. So when we are giving the pressure, it is coming down, and when you are releasing, it is going up.
Yeah, Asma ji, you can.
Sir. Good evening, sir. Sir, as you said, like when we are applying the pressure, so according to Pascal, sir, the pressure is which we are applying, this pressure is increasing inside the bottle, so it's distributed equally. So even the upper level of the water, it gets into high pressure. So because of high pressure, some water enters inside that water, a small bottle also, which is kept inside, and so that's for this reason it's going down.
But ma'am, there is no space inside the bottle. It is containing air and water.
So it's a way, because from outside when we are pressing, the pressure is distributed in the water. And
Yes, I'm saying that the bottle inside, there is air and water. So how the water will enter? Anyone else, please?
Yeah, there is one text from the participant. Pranita ji is saying it may be due to the concentration gradient and pressure.
Concentration gradient and pressure.
Yeah. Saurabh ji, yes, you can. Okay.
So in this particular case, we are increasing the pressure on the outermost bottom. And on increasing the outermost pressure, increasing the pressure in outermost bottle, the pressure on the inner bottle increases and it moves downward. सर हम सिर्फ ये कर रहे हैं कि सर आउटर बॉर्डर से प्रेशर इंक्रीज कर रहे हैं. As water is little bit compressible, so we are increasing the pressure. And with increasing pressure, the pressure is uniformly divided on the smaller bottle, which goes down.
Okay.
Anuradha ji.
Actually,
yes, sir.
So,
sir, can
yes, please, please.
Yeah, actually, sir, the bottle is partially filled with water and partially filled with air. Now, when you press the bottle, the liquid, the pressure, external pressure which you're applying is equally distributed all through, right? The liquid is incompressible, so it does not get compressed. However, the air inside the bottle is compressible, so it gets compressed. As a result, the space which is created is taken up by the water which is there. This leads to a higher level of water inside the bottle and lesser level of air. That makes the bottle a little heavier, which makes it eventually come down. As you release the pressure, the air again expands and the water level goes down, making the bottle with water and air lighter. Therefore, it moves up.
Yes, ma'am, you are absolutely correct.
Verma sir wants to add something.
Yes, sir.
I just wanted to confirm people know that the bottle is open from bottom side.
Yes, it is open, sir.
Yes, yes.
Your bottle is open on the bottom side, and this water can go into that small bottle and come out of that small bottle.
Yes.
Okay.
But I have another bottle, and you can find that there is already the similar bottle which is partially filled with water and partially with air. It is there. So let me move little. You can see that orange thing, but here when I'm pressing, it is moving out up, and I'm releasing, it is coming down. It is settling on the bottom, and when I'm pressing it, you can find it is going up, and when I'm releasing, it is coming down. So if fast case that is possible, then how it is possible? So you can see when I'm pressing, it is going up, and when I'm releasing, it is coming down.
And same thing is given.
Same thing is given. Even in this bottle, I also have two. You can see the blue one, when I'm pressing, it is coming down. And when I'm pressing the bottle again, the orange one is rising up. So in same bottle, same medium, same everything, same setup, only.
Okay.
So.
Okay. Now the second one, sir, it has initially a higher level of water inside.
Yes.
Right?
Okay. Yes.
And the air is less. However, when you're pressing it, then what is happening?
Sir, ma'am, I'm pressing in both cases.
Yeah, you are pressing in both. The yellow bottle initially has higher level of water in it. So
Yes.
it is heavier and it is settling down. But when you're pressing, then why is it moving up?
So that we are asking or you are asking?
Yeah, understanding a problem is itself something very important.
Well, sir, you can
Yes,
please
and you can
explain
find
that.
it is going up. And
Once again you show, sir. Sir, again you just again repeat it. Yes.
So can you observe the pattern of pressing in the two cases?
No.
Okay, sir, please show it once again.
दोनों बोतल एक साथ दिखाइए.
But okay, इसी में दिखाते हैं. So I'm pressing, it is going up. You can see the orange.
But the other one is
going
not
up.
coming down.
No, it is not coming down. Ma'am,
Sir, I think now.
I am pressing, ma'am, again. Now it is coming down. Again, I am pressing.
Something to do with the air inside the bigger bottle. Is it?
Ma'am, there is no air. It is fully airtight. Means it is filled with
Okay.
water and it is fully airtight. No air is there.
Okay.
Ripita ji? Yeah, you can unmute yourself.
So I can officially hand over the session to our respected Professor H C Verma, sir. From here now onward.
So thank you. It was a really very interesting session, and this last one is still puzzling, and I will not reveal what Debmalya is doing. But one thing I will say that if you are looking at some experiment, look at it very carefully and minutely. And if you look at very minutely, he says that in both cases I am pressing, and in one case it goes down, in one case it goes up. That means that pattern of pressing may be different. All right. So you have to see all these aspects very minutely, and if you observe it, if you can observe it carefully, probably you can reveal the secret. Okay. So very nice. In fact, ability to design new experiments, that is very, very important. And that I'm seeing here in both these resource person, Debmalya and Nani, that they can think of new experiments, they can design of new experiments, and then perform, and then come out. So that that vision that I can create something new, it should be there in our teachers. So very nice. So I also have some experiments for me. And we'll go by that. So the first experiment is again, it corresponds to that field of optics. Generally, what people do, they will show you the apparatus. They will show you the experiment. They will conduct the experiment, and you will see that experiment being conducted. And then finally, they will discuss or they will show you the results. So I will be reversing this order. I will not show you the apparatus. I will not show how I am doing the experiment. I will show you the result. Okay. And then you will have to guess what apparatus it is, what kind of thing I have used, and so on. All right. So I am going to the result of my first experiments directly. This is the final result of my experiment. What you can see is, if you see it very carefully, and with resolution, you can see you have a very bright area in the middle, and then there is a gap, and then there is again bright, and then there is a gap, and again bright, and again this bright gap, both sides of the center, you have this particular pattern. Now, if you observe, as I said, observation is very, very important. So have a keen observation. The central one is wider. The central bright one is wider, and the other bright ones are smaller. But those other ones are of equal width, right? The central one is almost double the width of the other bright lines. And between two bright lines, you have this no green light there. So that is the dark part of it. Now look at the intensity. As you go away from the center, these dashes which are there, gradually the intensity is decreasing on the lower side as well as on the upper side. Now my question, what experiment is this? What is my apparatus and how I'm producing this result? So that you have to tell. Diffraction pattern, good. Apparatus required, laser, good. Very fine. Diffraction, good. Yes, it is diffraction. Single slit, okay, very good. Single slit. And I'm putting this laser on the single slit. Very nice. Now, I will be changing something in my apparatus, and you keep looking at this pattern. Amit, can you hold the camera? Focus on the pattern. Now, look at this pattern. You do have a bright central line. And then you have these dashes as before. But if you do a very keen observation, can you see any difference between the patterns that you had seen earlier and that you are seeing now? Yes, stay put there. Don't move. Yeah, okay. This was the first one. This was the first one. Look at this pattern very carefully. It's two figures, two images you will be seeing, and not side by side, of course. And then you have to find the difference. This is the second one. This is the second one or first one. Adjust करिए थोड़ा सा उसको बढ़िया. Yeah. Hold it, Ranjit, hold it. So this is that second pattern. So do you see any difference in the central thing that you have seen there? Or these dashes? Can you see any difference? Can you see any difference between the first image and the second image? Subsidiary maxima. Okay. So are you able to see the difference? This is your first image. And go for the second image. Go for the second image. This is the first image. Go for the interference. This is like that first image. Yes, stop. This is your second image. What differences do you see in the two images? Answer. Do you see any difference? Do you see any difference? There are several differences. Any bright one you see, central one or any one above that central. In each bright, you can see further 3 or 4 bright and less bright and bright and less bright. Okay. For example, if you see here in this particular bright one, inside that you can see dots. Can you see now? Please answer. Can you see a fine structure of those dashes?
Yes.
Right? There's a fine structure. Then the gaps are much more discreetly visible as compared to the first one. We can go back to the first image, but just see it once again. In each of these dashes, bright dashes, you can see a structure. Here. You can see a structure. And if we go for the first one, first image. Amit, make it first image. Okay, this is another kind of. The third kind. Just stop. Amit, just to stop. The third kind of image. This is a third kind of image. All right, go to the first image. Yes, this is it. This was the first one. Don't see any structure inside. All right, and the separations between these two, this gap is less sharp, and in the second image, this gap was quite sharp. So these were the distances. These were the differences. Now tell me. Now I'm going to show you the operators. What do you think? What was my operators? In the first case, in the second case. Before I turned my camera to operator side, just make a guess. What was the operators in the first case and what was the operators in the second case? गोविंद जी, आप सभी को अनम्यूट करने का परमिशन दे सकते हैं क्या 1 मिनट के लिए?
जी सर.
सभी को अनम्यूट करने का परमिशन दे दीजिए. जिसको जो बोलना है चिल्ल पो करो.
Okay, yes sir. Your time starts now.
Is the first one single space and
Laser and your hair.
Slit and double slit.
Laser and hair.
Your hair.
My hair.
I think in first case 1 hair and second case 2 hairs are there.
Okay, first case 1 hair, second case 2 hair. Very good.
Single slit and
Single
double
slit and double
Single
slit.
slit and double slit.
Single slit and double slit. Very good.
Single
Very
slit
good.
and double slit.
Very good. Wonderful. Wonderful. Single slit and double slit. All right. Very good.
We can use
Let me
pencil
show-
leads. Pencil leads also we can use.
Pencil lids. Okay. So now let me show what I have used. All right. So I'm going towards my operators and look at my single slit and double slit and whatever you think. Can you see what it is? Can you see what it is?
A
Can you see-
razor blade. It's a razor blade.
Razor blade. Razor. Which
It's a razor blade.
Which kind of? Ready-made hai?
Ready
All right.
shaver.
I have not
Gillette
cut
shaver.
the blade and put it there parallel to each other, this and that. I have not done anything. The same razor that I use
It's a
every morning.
simple razor. I think triple blade razor.
Right, right. In fact, it is 5 blade laser.
Triple bed
Okay.
Mac 3 result, sir.
It's 5. So this is the one which I use every day, and it is 5 blades. But my laser beam is not that wide enough to cover all the 5 blades. 5 blades will make how many slits?
It will
5
make
bl- 5 blades will make how many slits?
4.
4. Right.
slits.
Right, 4. So the laser is not falling on all the 4. By making some adjustment, I can make this laser fall on 1 slit. That was image 1. 2 slits. That was image 2. And 3 slits also. You also saw a third kind of pattern. That time it was partially falling on the 3rd slit. Okay. So which was interference? Which was diffraction?
In second, diffraction and interference both.
In second, interference.
In the
and-
envelope of the
in single slit
first diffraction,
diffraction,
second interference, and diffraction.
doubling interference.
Okay. Can you have pure interference with the double slit?
Sir, we
No.
can have, but we have to have many adjustments.
You have
The
to
part
make-
difference, the part difference should be perfectly perfect.
Which
It is
distance
always
should-
being advised to have a single slit, to have a perfect part difference of single wave. If we are having a double slit experiment, then the part difference should be of both slits should be same.
Oh, path difference is different at different places in the pattern. All right. Path difference is different in different places in the. That is why you have a pattern. If the path difference is same, then you cannot have a pattern.
Right, sir.
At all different places, in that whole big pattern that you've seen, some 14, 15 fringes on one side, 14, 15 on the other side. Path difference is continuously changing. That is why at some places you have dark, at some places you have bright. Okay.
Sir, can we do
This
that?
razor blade that I'm using now is extremely good slit and combination of slits. Perfectly parallel. Okay. The separation between the 2 slits is exactly equal. First, second, and second, third, and third, fourth, exactly equal. Very sharp. Very sharp. So it's an extremely good diffraction and interference apparatus. And that is why you see such a good resolution of the fine structure of the fringes. Now, to get a purely interference fringe, and how do I recognize whether it is a purely interference fringe or not?
So if the central fringe is maximum and all another are lightened, then it's a diffraction one. If another are having the same brightness as the central one, then it will be taken as the interference spectrum.
So
In the
in our
second
case, what it was?
In first case, in which the central was double of the width, it was diffraction. and when it was having a P of same intensity, it was interference.
Yeah, in the second case, was the intensity same everywhere in all the fringes?
No,
It wasn't. I think the second one.
In the third case, practical difference. That is the practical difference in the topic.
Okay. So I can perhaps we will not get a better double slit than this.
Of course, we can say that.
Yeah, and therefore, in any real experiment of double slit, you will have a diffraction pattern, and you will have an interference pattern. Okay, let me draw a diagram on the board. Let me draw a diagram on the board.
Sir, may I ask one question?
Yeah, just a minute. Let me draw a diagram on the board. See, if you have this diffraction pattern, single slit, if you have single slit, then what you have, the intensity is of this kind. You know that, right? You have a central bright, quite intense, and then of course you have less bright, and you have less bright, and so on. Now there's also a question for you. In the diffraction pattern, the book says that this intensity ratio, this and this, the intensity ratio is 22. If this is I0, this is I0 by 22. And then this is perhaps I0 by, I don't remember how much, 50 or something.
I think 144.
In our pattern of diffraction, the first image, do you think that these kind of intensity ratios were there?
No, sir.
This is one. Now, in the second case, when you have double slit, so this is single slit. Now I'm going for the double slit. So if you have double slit, what happens is each slit has a bit, and correspondingly there is a diffraction pattern like this. But because of these two interference between them, you have intensity varying inside this also. It goes like this. It goes like this. So you have several zero intensity points inside this central thing.
Sir, you are a very good teacher.
And similarly here also, you have intensity pattern of this, something of this kind. Something of this kind. So this was the fine structure that we were seeing. This was the fine structure that we see. Central was too bright and therefore it was difficult. But the side ones, you could see those patterns very easily. Those fine structures that, so you have dark in between and you have bright here. So that kind of thing that you get from the double slit, right? But for textbooks, the double slit pattern is not like this. Textbook double slit pattern is, intensity pattern is like this. That is how the textbook describes I equal to 4 I0 cos square delta by 2 or something like that. All right. Now, since it is slit, when you make a slit, very nice slit, you will always have this kind of pattern. You will never have that textbook kind of pattern. Okay. So this is for the first experiment. Any comments? Any comments?
Sir, of course, there is always a difference between the theoretical and the practical knowledge.
Sir, I have one doubt, one question.
Yes.
Sir, I heard that we can find this type of pattern by using hairs also, right? By using hairs. Okay. I have tried, but I was failed to get such type of pattern with hair. Is it possible, sir? How we can do this?
See, single slit you can imitate. If you have a single hair which is straight, right, and make your laser fall on that. So although it is not a slit, it is an obstacle.
Obstacle.
Your hair is obstructing the light, but somehow the effect is exactly identical. If you have the same size of slit, and if you have the same size of this hair or wire or obstacle,
Okay.
It so happens that the pattern is identical. So that first image, that the diffraction thing that I showed, that you can get with the hair, and it's not very difficult. But double slit, making double slit with hair is a Herculean task. Because the two slits should be having the same width and parallel and this and that. That is very, very difficult.
Okay.
Although
Thank
we
you,
had
sir.
tried that, and we did get some results, not very good results. But this particular apparatus that I found was extremely useful.
You can do
Okay.
this by finger also. We can put the finger in the path of the light.
But can you see this kind of resolution?
No.
Can you
no.
see these kind of 30
No.
fringes, 15 fringes on one side and 15 fringes on the other side? And inside each fringe, you are seeing the fine structure.
No, not
See,
at all.
with so experimentalists always look for better apparatus.
Just for the demonstration purpose. Thank you, sir.
Yeah, this demonstration. And there's nothing great. Nothing great. These razor blades are so commonly used.
Excellent, sir.
And then one laser.
May I ask a question here?
Okay.
Yeah, when we talk about a slit, we mean opening, a small opening for the light to pass through.
Correct.
And I know that when we use hair, we get a diffraction pattern, but basically hair is an obstacle and there is provision for light to pass from both sides. So how does it give a diffraction pattern, which is similar to what we are seeing in the book with the slit?
Yeah, yes. Yeah, okay. That could take time, and it's more theoretical. Okay, so maybe we can have some session on that also. It's called Babinet principle, right?
Okay.
And mathematically, it is proved that the two things are identical. The obstacle and the slit of the same size will produce identical diffraction pattern. That is theoretically proven. Okay, so we can give the justification with some theory, some calculations, but that may be a separate topic. So let me move to another experiment. So just keep quiet, okay? You can stay unmuted, no problem with me. And let's look at the second experiment. Now this experiment is, can we start? This experiment is on electricity, and you can see what you have. Can you show this coil? क्या है हाथ में? नहीं, अच्छा, एक चीज लेके चलते हैं. You can see this one copper coil with an LED. What color it is? Can you tell? Experiment ही मत कर दो. I think red. All right, one is red, one is blue, and one is white. Red and blue. अच्छा, red and blue. The three. तीसरा क्या है? Oh, that is the ring. Okay. Forget that. So you have two copper coils, and in each coil you have an LED. One is red, one is blue, and then you have this. This is again a coil for several thousand turns. I don't know, 15,000, 20,000. Those many turns in the lower side. And on the upper side, what you see is cycle spokes. So the coil, the space, near the axis, the empty space has been packed with these cycle spokes, right? And then the two ends of the coil, the lower coil, those 20,000 turns, that is going into main power. That is going into the main power, and there is a switch which will control whether you want to allow this current in the coil or not. Okay, so you may have seen this experiment, very, very common demonstration for, okay, I will ask you for what? It's called jumping ring operators. Okay, let's show that jumping ring also. There's an aluminum ring. Yes, we put it there, and then we pass the current, and it jumps. So it's called jumping rings. I will not ask questions on that, remove that. So today, this experiment is also for light only, and let us put one of these two. One of these two. Put it there. Now switch it on, and you can see it's a red light. Okay, red LED. All right. And if I lift this little bit, yeah, lift, it's still glowing, and now you can see the intensity is becoming dim. Okay, go further up, off, almost off. No intensity in the light. Come down. The light has started appearing. Note this position. No, go up, stop. Up to this height, this LED is glowing. So just have an estimate of this height in your mind. Right, now the next coil. Yeah, switch it on. This is blue LED. Okay, go up, gone. Go down. Yes, it is there. Right? Yes, it is there. Go up, and it is, the intensity has almost gone. All right. So now questions. Why is there a difference between the heights up to which it glows in the two cases?
Sir, is the number of turns in each coil the same?
Is the number of turns in each coil is same? Yes, it is same. It is same. It is similar coil. Only the LEDs are different.
Excuse me, sir.
Yes.
Actually, the area cross section of both the coils are different, sir.
Put one over the other.
I'm able to see what I'm able to.
Yeah. See both the coils.
So there must be difference in number of turns of each coil, sir.
They are equal. Believe me, they are equal.
Sir,
Is there a difference in the power required to light up the LED?
There's a difference in the power required to lit that LED.
That is the frequency difference, I think, sir.
Which frequency?
Sir, I'm not exactly available. The difference in the wavelength and even in the frequency of the both lights.
Yes, difference in the wavelength of the two colors.
And due to the wavelength, it is something like that.
Right. So there is a difference in that red wavelength and this blue wavelength, correct? Then?
So due to which electromagnetic which is being produced, this electromagnetic induction, that changes its current amount.
Sir, since sir, the area of cross section, number of turns, and the material, everything is same, so equal amount of induction is happening or EMF is produced. But the LEDs which we are using, they require different power or different energy consumption, and that's why the okay. Thank you, sir.
I am agreed, sir. Same thing.
The red LED needs lower voltage, okay, because it's a semiconductor device. It is diode, right? Light emitting diodes. So you have this semiconductor, and in that semiconductor you have a connection band, you have valence band, there's a band gap, okay, and the light is emitted when this electrons are transferred from the lower valence band to the upper conduction band. And to make that possible, that EMF is required. Now, in the case of red LED, this band gap is less, and therefore less amount of EMF is able to make those electrons jump, and then you have all this phenomena. Whereas for blue, the band gap is larger, and therefore you need larger EMF. And as you go up, the EMF decreases. In that jumping ring apparatus, as you go up, okay, if I am here, when the switch is on, if I am here, the EMF produced in this loop is more, and the EMF produced in this loop is less.
Yes.
Why? Why it is so?
Sir, actually,
So
due
the
to less magnetic flux.
flux will be, yes. The
Magnetic
magnetic flux actually decreases at larger distances, sir.
right.
Magnitude of
magnetic
So
flux.
less change in the magnetic flux is occurring at
Greater-
a higher level.
And okay, magnetic flux has two components in it: magnetic field and the area. So what is decreasing as you go up?
I feel, may I say?
Yeah.
Yeah, as
Field.
we go away on the axis, the field is decreasing. The area is same.
Yes.
Area is same. So effectively, the flux is decreasing as we go up.
Correct. Correct. The magnetic field, magnitude of magnetic field is decreasing. The magnetic field is created by
This coil
Lower
which is
coil.
at the base.
Coil,
right,
yes.
and therefore the magnetic field lines will be something like this. Okay.
Yes.
And therefore, as you go up, many of the lines have already gone out of this area, and therefore the magnetic field is decreasing as you go up. Why are these cycle spokes? What is the role of the cycle spoke?
They are increasing the intensity of magnetic
Concentration,
field.
yes.
Overall, if this is not there, if it is not
magnetic
there,
field lines will pass through these and they will be highly magnetized and they will induce the electromagnetic induction.
correct.
Sir,
So as I say that as you go up, the magnetic field is decreasing. If these spokes are not there, then the magnetic field will decrease at a much faster rate.
Yes.
Okay, much
Yes,
faster
sir.
rate.
Yes,
So
sir.
that's the role of this. It tries to take the magnetic field along with it, but then yes, it
Increase.
tries. It does, but some of them still leak out. Okay, so this is about this. Let's go for the third one.
Sir, may I
Let's go
ask
for-
one question, sir?
Yeah,
Sir, may I ask one question, sir, here?
yeah, please go ahead.
Is there any role of ED current here, sir?
Depends on what you call ED current. Depends on what you call ED currents. The mechanism is I am passing a 220 volt AC in the lower coil.
Right.
Okay, and that is creating a magnetic field. And that magnetic field produced by this current in the lower coil oscillates with time because it is 50 hertz AC.
Right.
Right. Now this oscillating, this changing magnetic field produces some kind of an electric field around that coil, around that spokes,
Right.
like this. And then once you have some material there, like this coil, then that electric field drives the current. And we say that, okay, there is an EMF induced. This is the physical mechanism. Step one, current in the lower coil. Step two, the current is producing a magnetic field. Step three, the magnetic field is changing with time.
Right.
In this direction, dominantly in this direction. And step four, this changing magnetic field is creating an electric field in this direction. Step five, since there is a conducting loop there, this electric field drives the electrons along this loop and you have a current.
Correct.
So if you want to call it eddy current, yes, eddy current is there. If you say that it is just a current, you are applying some electric field to the electrons and it's moving just like battery. In battery also you do that. You apply some electric field and the free electrons start moving. So,
sir, but in case of the first case, the aluminum ring, which one is dancing around this core, there it is only due to the eddy current and their same polarity.
Once again, same story. If you want to call it eddy current, I have absolutely no objection. Okay, but the mechanism remains the same. It is that electric field which is driving the free electron of this aluminum ring, and because of that current, it is jumping and is oscillating because of the inertia of motion. And after some time, oscillation will stop. After some time, it will damp out, just like your pendulum.
Right.
And then it will stay. Then it will stay at one place. No, it will keep hanging.
Right.
Okay, let me show that. Give me the ring once again. Power. Yeah, the power. Aluminum ring. See it oscillating, and then it stays there. My hand, I'm holding it, so my hand is shaking. So some small motion you can see, and especially when I speak.
So the magnetic force between these two are equal and just opposite. Hence it halt at that particular height.
Between what?
Is working, sir.
Sir, the magnetic force between the same polarity due to ED current, sir. The magnetic force and the weight of that ring just
Okay.
balances each other.
Okay. So let's go for the next experiment. I have a meter. What is this?
Multimeter.
Meter.
What does it measure?
Current as well as
Current and voltage.
Sir, I can't see it clearly.
This is a very special kind of a meter. It's a very special kind of a meter. It does not
Capacity meter.
measure voltage. It does not measure resistance. It does not
Capacity.
measure current. It measures capacitance. Okay, it is a capacitance meter. And let me show you some experiments with this. Let me show you some experiments with this. Let me make my own capacitor. Let me make my own capacitor. The first capacitor we will be making with our thalis. So we have two thalis, steel thalis. These are our capacitor plates, and separated by a polythene sheet. Does it make a capacitor? Does
Yes,
it make
sir.
a capacitor?
Yes, sir. The plastic sheet acts like a dielectric medium.
That plastic sheet is dielectric. Wait a minute. Now this is a capacitor. You have two metal plates. Is it a parallel plate capacitor?
Of course, it would be taken as
Largely.
circular parallel plate capacitor.
It's largely a
Yes,
parallel
sir,
plate
yes.
capacitor. Okay. All right. So let's measure the capacitance. So the two dishes will be connected to our capacitance meter. One is already connected, and the other one is connected. And this scale is in nano farads. So 0.160 nanofarad. That means 160 picofarads. That's the capacitance of this capacitor. All right. Now tell me, if I increase this dielectric, I put one more sheet in between, what will happen?
The capacitance will
Capacitance increases.
Capacitance will increase. Exactly. Exactly. Very good. So put second sheet also. Put second sheet also. What has happened? It was 160. It was 160. Now it is 133.
May I say?
Yeah.
We have increased the separation also in the process of introducing another sheet.
Exactly.
We had maintained the separation.
Very good. Very good. So you can create these kind of situations which will force the viewer, or maybe your student, or if you are giving a workshop to teachers, it will force the viewers to revise those formulae.
Sure. Excellent, sir.
Thank you, sir.
Okay, so let's make some more steel glasses. Similar story. Just to tell that. Another thing is, if you just have a rectangular plate, that will not put that much of excitement in your show. But if you use your kitchen materials, the glass tumblers and those steel thalis, then the excitement will be much more. So once again, there are two conductors placed side by side, and is it all on? 0.005, 5 picofarads only. The capacitance here is 5 picofarads only. Put one into the other. Put one into the other. – 48 picofarad. What kind of capacitor is this?
So it would be taken as
Cylindrical capacitor.
Cylindrical.
Cylindrical.
So in your kitchen, you have parallel the operators for parallel making parallel plate capacitors and also cylindrical capacitors. And if I can go further inside, yes, very good, very good, very good. So now the capacitance has increased. It has become 160 picofarads. So what has increased?
The area that they were facing with each other. The area.
Area. And area of the plates which is facing each other, that is important. Right? The tumbler has same area. Each tumbler has the same area. We are not changing the area of any tumbler. But the area which is facing each other, that is being changed. And that comes in your capacitance equation, whatever, epsilon naught, whatever. So that it is there. Third kind of capacitance. Third kind of capacitance. Once you have these things, you can make varieties of trials yourself. These are just two wires. These are just two wires. Okay, one wire and okay, there are two wires. Okay, there are two wires. And we are just connecting our meter to the two ends of the wire. And two ends are still floating. Where are the other two ends? These two ends are still floating. And you have a capacitance. 22 picofarads. It makes a capacitor. This also makes a capacitor. Two wires placed side by side. Okay, now open one clip. Yellow one. Open a yellow one. Open this clip. Now what we will do, we will put this clip at the other end of this yellow wire. Other end, what will happen? So one wire is connected to one of the terminal of this capacitance meter is connected to one of the wires as such, and the other one I have opened, and I'm only changing the end. So where was the first time where we connected? We connected it here. Now we are connecting same wire. We are connecting on the other side. Do you think there will be a change in the capacitance?
Don't think so.
It will change.
Sir, the wire is the same or different wire?
Same one. That is why we have put this yellow end so that we can recognize
this
yellow.
So we are changing a particular end. So the capacity will change, but not sure of it. By what value it will change?
I don't think that it will change.
It will not change.
It will not change. It will not change.
Okay, so this is another message. Create a situation before telling what is happening. Create a situation where they are allow some time to think. Allow them some time to think. And if there is some confusion and disagreement, it's even better. All right. And then you do the experiment and show the result. Yeah, connect it. All right. Same capacitance.
It has increased.
No, it was the same thing. It was the same. It was the same. Connect it back. 21 here. 21 here.
Yes.
Okay. So once you connect this wire to any source, this entire metal piece is at one single potential. Right? So put that at one end or the other end. It's not current. There's no current flowing as such. It's open circuit. So in open circuit, electrostatics, the entire metal is always equipotential. So it's at the same voltage, same potential. So whether you connect it that side or connect it that side, two wires will see no difference because they see that okay, earlier also it was at these many volts everywhere. Now also it is at this many volts everywhere. Okay, so one more experiment I will be showing, and then we will.
Sir, what is the name of this capacitor, sir?
Line charge
capacitor.
You give it a name, a nice name.
Line charge capacitor.
A line charge capacitor. Good, very good. Very good.
Sir, if it would be closed loop, then
Pardon?
if it
I
would be closed,
if I close, then I will make a short circuit. Right? Because on one side we are putting this will become one metal. Right? If I close it at one end and the two ends are connected to the capacitance meter, then it's a single wire. It becomes a single wire. Jara jod ke dikhana. The two wires bring two wires. Capacitance chhod diye, meter chhod dijiye. Just take out those two. And suppose bring it here. No. Bring it there. Now suppose I add them. I connect them. I've connected them. Is it not a single wire?
Yes, sir.
yes, sir, yes.
Is it not a single wire? So then it will not make a capacitance. All right. Now the next experiment. This is a very simple, simplest kind of circuit that you can teach in your class 9, 8, whenever first time Ohm's law you are talking of. You have a resistance, and then you have a power, you have a voltmeter, you have an ammeter. Okay, just a series circuit. Make a series circuit. So I'm going to resistance, and then from resistance, remove the extra wires from the table. So this heater coil is the resistance, and this resistance has to be given a power. Voltmeter chhod do abhi, don't touch the voltmeter. Make the circuit complete through the ammeter. Yeah, this is the series circuit which is complete. Okay, now give it some power. Okay, all your preparations were incomplete. Okay. Okay, try it. Okay, try it on the other table. In the meantime, you bring that. Semiconductor. We have a PN junction, right? We have a PN junction and a multimeter. Bring the multimeter and the PN junction. All right, this is another apparatus. Wait. This is a multimeter. And you also see water in a glass cube. Okay. And then the coffee heater. We are not going to make coffee anyway. Okay. Yeah, put that heater into the water. We will heat the water. We will heat the water. That will be heated. Yeah, you bring that PN junction and measure the capacitance of that resistance of that PN junction. You have already connected? No. Show where is the PN junction. Bring it closer to the camera. This is a PN junction. It's a semiconductor device. There are two ends. One end is connected to one end of this multimeter and connect the other one also. Show the reading in the resistance mode. it is in kilo ohm range. So it is 438 kilo ohm. Okay. Now reverse the connections. Reverse the connections. Yeah. See, the resistance is too high. It is not showing. Change the range. Change the range. Further. It's not showing, right? Okay. Go back to the original connections. .438 ohms, 0.438 kilo ohms. Your water is hot by now. Put it there inside the water. Remember, only the PN junction should go into the water, not the clips. Only the PN junction should go in the water, not the clips. See what happened? Resistance is decreased. We have increased the temperature and the resistance has decreased. Right?
Conducting material.
So in semiconductors, when you increase the temperature, the resistance decreases. Why does it decrease? Yeah.
The number of holes and electrons are more.
The number of holes and electrons are more. Why are they more?
Because the heat
Because
energy
bonds are broken, sir.
Right. Right. When you increase the temperature, you are giving energy, and that energy breaks more bonds, and therefore you have free electrons and free holes, which conduct the electricity better. Right. On the other hand, if you have a metallic conductor, not semiconductor, metallic conductor, you have lots of free electrons, and by increasing the temperature, do you increase the number of free electrons? Do you increase the number of free electrons?
Yes.
By increasing the temperature of a metal,
no.
Do you increase the number of free electrons?
No, sir. No, sir.
In fact, collision increases and this increases the resistance.
While motion of the electrons increases.
Relaxation time
All
decreases.
the speed already each atom has given the loosely bound outer electron into conduction, right?
Yes.
That is already free. Each atom has given whatever electron can go, it has gone. Now increasing the temperature will only increase the kinetic energy, the thermal energy of these free electrons, not the number of free electrons.
Exactly.
And these more vehemently moving electrons, when they try to move in one particular direction because of electric field, then the resistance is more. If they are going slow, they can find their way and go ahead. But if they are fast, then it's very difficult for them to really go through that metal, and therefore the resistance increases. So these are the differences in this processes, in the mechanism of semiconductor heating and the metallic conductor heating. Okay, they are ready with this series circuit once again, and as they think, then let us see what it is. So we have this heater coil. Hey, ruko. Wait. And okay, that shadow, that light shadow is there. थोड़ा हिला के दिखा दो. नहीं, wire का shadow पड़ रहा है नीचे. It looks like it's a separate wire. That black one. हाँ, ये देखो. So you just have yeah, okay, this is better. This is better. This black thing which is coming from right is the power, and then the two ends of the power are there. They are connected to this heater coil through the ammeter. Now put the voltmeter also. Across the resistance. Put it on the left. But Amit, put it on this corner. Yeah. So one end here, another end there. So we will be measuring voltage across the resistance, this coil, and we will also measure the current through this wire. So both things we will be measuring. Okay. Now let us see. Now let us see what happens. Okay, so let me show you the reading of the voltmeter and ammeter, and you will have to calculate the resistance. Voltmeter first. Can you see how many volts?
Sir, approximate 2 volts.
0.2 volts. Is 2 volts.
1.9 volts.
2 volts.
How many amperes?
6.25 ampere.
0.25.
2 volts.
0.2 probably.
0.25 amperes. What is the resistance?
8
ohms.
8 ohms. Very good.
8 ohms.
Now, we will be changing the voltage. We will increase the voltage from 2 volt to, let's go, how 4 can be? Yeah. थोड़ा से कम करो तो 4 से थोड़ा ज़्यादा हो रहा है. थोड़ा और नहीं, increase the voltage. Increase. Yes. Stop. Decrease slightly. Very slightly. So what is the voltage now?
4 volt.
4
volt.
What should be the
4.2.
current? Yeah, it's 4.
It should be 0.5.
It should double. It should
So what
double.
should be the current?
0.5.
0.5. And look at the ammeter now. Look at the ammeter now.
Oh, 0.5.
No,
it's
0.25 only.
It is 0.25 only.
0.25.
0.25.
Slightly more than that.
No, slightly more than that. Yes.
More than that.
Only slightly more than that.
Slightly more. Very slight
Yes.
difference.
Slightly more.
Oh, yes.
Yes, it's around how much? 2.6 or
0.26.
2.7. What happened? What happened to Newton?
Sir, the coil got heated up. The coil got
Inductive
heated
heater
up.
coil.
So due to
Yes.
coefficient, thermal coefficient, the
Right.
resistance of
Heating
the
effect,
wire
the
increased,
resistance is
and therefore the current remained less.
Okay, when we increase the voltage, this coil got heated, and it has to be heated. I square RT will always be there, whatever you do. Once you pass a current I in a resistance R, the thermal energy will be produced at the rate I square R. You cannot escape that. Unless you maintain by cooling or these things, you maintain the temperature, do some extra work. And therefore, Ohm's law, V by I is constant, voltage is proportional to current, or current is proportional to voltage. You will not be able to demonstrate in general. Okay? Unless you change the current in extremely small amounts so that the heating is very, very small.
Yeah.
Okay. So create the situations where people forget. They know it, but they forget to apply. And then when you show it up, then they remember that, they recall that, okay, yes, this phenomena is also there. So that kind of training the minds to think, that is our purpose. As a teacher, we should plan to create situations so that they start thinking the way a physicist should do, a scientist should do. And to help them in orienting their minds that way, we should create these kind of small experiments, create situations, make discussions, and do physics. Thank you very much.
Thank you so much.
Thank you so much, sir.
Thank you so much.
Thank you, sir. Thank you so
Very
much.
interesting,
Thank you
sir.
very much. We are looking forward for more sessions,
Over
sir.
to Debmalya.
Wonderful, sir. Thank you, sir.
Session. Debmalya, sir.
Yes,
The
ma'am.
answer, we would like to have the answer to that question, that why when we go to
Pressure.
the polarizer.
The bottle pressure.
Polarizer.
Pressure wala sir, pressure.
What you can do, Debmalya, what you can do is already
Sir,
close
एक
to
question था
8
सर.
PM. You can make video answers and post
Okay.
to
Okay, sir.
all the participants.
Okay,
That's
sir.
my suggestion. That's my suggestion.
Sure, sir. Sure, sir. I'll do. And uh, we are at the end of the program. I'm going to post a feedback link. We need your feedback. So that is very important for us. That gives us the inspiration. Your encouragement is our inspiration. And if you are interested, we can keep you in touch. Our future upcoming programs. As you know, we are having a next series of experiment skill tests for the students. And then sir always keep running the programs on different models of BSc programs and other models, so we can keep you informing. So we can do that. And video is not ready with me. Somebody is asking for the video. I'll definitely make it and I'll post it. I have a YouTube channel. You can search with my name, Debmalya.
Muted. Muted Debmalya.
Yes, I'll definitely post it there, but it will take 2 days because sir already give me some 1 week time to give 2 videos to him. So I'll be doing that first and then I'll do this. Anybody want to say anything is most welcome. All the participant and Nani team, anyone want to say anything?
Sir, one question is there from the sir. That question is that in case of inserting 2 glasses, if we are going to insert the 3 glasses, then what will be the capacitance? Whether it will increase or decrease?
Tell me whether it is
Verma,
series
sir?
connection. It is series connection or it is parallel connection.
Series connection.
Will be
And
there.
in series connection, what should happen?
Capacitance decreases.
That's it. But yeah, so if you can get hold of a capacitance meter in your school or somewhere, or in some science center, or maybe the Malaysian, then you can do such kind of experiments in your kitchen and come out with results.
Sir, do we have any such sessions in future, sir, for our help? Sir? Any other such sessions? Can we expect?
Yeah, if you organize,
You are a
fine,
very
I'm
nice
there.
teacher.
Excuse me, sir. In feedback, we have given all the option. If you want to organize, we'll revert back to you and we can set the time and we can have sessions. Please fill the feedback form from where we can collect the data and we can understand what you want and we can make ourselves ready for that.
Basically, sir, in workshops, people get bored. They want.
Sir, after the workshop, sir, whatever feedback the students are getting bored.
Wait, this is also a very, very important national task.
Sir, you are a very good teacher.
Oh, thank you very much. Thank you very much.
Sir,
So this is a,
sir,
this
may
is a
I
very
ask one
important
question, sir, my
national
side?
task. Wait. Let me give my
excuse me,
message.
sir.
Let me give my
one
message
question.
first. Let me give my message first. We need an army of resource persons which can make the workshops vibrant and which can enthuse the audience, the teachers, the students. Okay, so this is very important. As you say that in many of the workshops, we do not enjoy, we get bored. Because we have a dearth of resource persons who can present the things skillfully. So I invite all of you to make some effort in this direction also. Suppose you have to teach certain topic, any topic you can collect, you can think of optics or thermodynamics, some. So in what way do I present so that it really shakes the mind? And especially not go for students. That is for students. I know you have a lot of constraints also. Your board, your management committee, your principal, your first term examination, your second term examination. You have to finish the syllabus, this and that. Let it go as it is, right? Only put some 5-10% of extra things there which can train the minds. Say normally in our school teaching, we are not training the minds. We are telling them to understand what I am teaching. So this understanding is very different. and training to think in a particular way, that is a different story. All right. So in the normal teaching, you can put some 5-10% of your side from your side, so that together completion together with the assignment checking and those things, some thinking component can be given. Maybe 5%, maybe 10%. You may not have scope for doing anything more. But then even putting that 5% is not an easy job. It is a very difficult task. And therefore, training the orientation, training the minds of the teachers is important. And if you can think in this direction, any of you, if you come up, you take this as a side task, your personal agenda, that I will design a workshop for teachers, and there I will be creating situations so that not only teachers enjoy, but also they start thinking, they start observing things minutely, and so on. And if you do that, that will be a national service. So that's my message.